And that, kids, is aminoglycosides.
I don't understand.
I don't get it.
Well, then I guess there's only one way to show you.
Students, you have just been injected into a patient with an E. coli infection who's being treated with aminoglycoside antibiotics.
They are used to treat gram-negative infections.
Bacterial ribosomes are important because they act as the site for mRNA translation and are essential for the protein synthesis.
So where do aminoglycosides come in?
Aminoglycosides use transport channels to permeate bacterial cell membranes. Once inside the bacteria, they bind to the bacterial ribosomes to prevent bacterial translation and therefore inhibiting protein synthesis, causing the bacteria to die. Bacteria develop resistance when formerly susceptible populations are exposed to a decreased concentration of the antibiotic. Most commonly, bacteria resist aminoglycosides by modifying the drug with aminoglycoside modifying enzymes. These enzymes modify the shape of the aminoglycoside so that it cannot bind to the bacterial ribosome and translation will not be affected. Bacteria will continue to synthesize proteins and the infection will grow. Genes for these enzymes are often carried in small pieces of DNA through plasmids and transposons. They are passed on through conjugation. When the bacteria become close enough to each other, channels form and a copy of the plasmid with the resistant DNA is passed on to the neighboring bacteria. If the copied plasmid is transcribed and translated, the bacterium will then produce inactivating enzymes to destroy the aminoglycoside molecules. Aminoglycosides treat many diseases. If resistance spreads, then these infections cannot be treated and will be lethal. A contagious infection could potentially wipe out the entire planet.
So humanity is doomed.
Well, only if this resistance spreads and we choose to ignore it. It is important not to overuse the antibiotic. It is also very important to always finish the prescribed dose to ensure that all bacteria are killed and there are none left over that could become resistant.
Learn more about antimicrobial resistance at ppd101.rcsb.org.